So thank you very much to all the speakers for their presentations, and we can see that this topic of ARM versus RISC-V has quite a lot of different facets, and we want to spend, say, the remaining part of this event for first starting with a panel discussion, but we will open it, say, around 20 minutes to 6 the latest for also to the questions of all the participants. I would like to ask participants, if you have any questions, don't use the chat, but use the Q&A facility, because that will make it easier for us to, say, manage all your questions. I hope that this will give you a good opportunity to also have you in the feedback loop. Now, let me briefly introduce to you the panel. We try to have, say, a good mix between people with, say, if you like, different roles, say, coming more from the side of the HPC technology development, or from the HPC technology product supply side, or from the HPC technology customer side. That means, say, in particular in this context of high performance computing, from the side of the supercomputing centers. And with that, I would like to introduce, say, the first panelist, which has not spoken yet, as Daniele. He is an HPC specialist at CINECA, so he obviously takes the role of, say, representing, say, the European supercomputing centers, as with CINECA, say, being the host of the one of the Euro HPC pre-exascale systems. Then we have, furthermore, say, the three further people who say I have already met earlier as presenters. It's Jean-Marc, Denis. Say, until yesterday he was at Atos as head of strategy, but now he moved then to Cypel. But he continues to be, say, in the role of say, being, say, on the supply side actually, but now closer to, say, development maybe a little bit. Then Roger Ferrer, who I say gave the latest presentation, again on the HPC technology development side, more, say, on the software part. And then finally Fabrizio Magugliani from E4, where he is, say, responsible for strategic planning, as again also representing then say the HPC solutions supply side. Now let us start with say maybe the question, as we have been talking now with say technologies which are not yet, say, fully established on the HPC market. I mean, Fabrice has shown to you that it has been made quite good progress as far as ARM is concerned, but for RISC-V it's a slightly longer path to go. So I want to start with asking the question. I mean, if the bringing ARM-based solutions to the HPC market is still challenging, and probably for RISC-V it's becoming even more challenging, given now, say, your specific say background, coming more from the development, supply, or the customer side, what do you consider as being, say, the main challenges for increasing, say, the uptake of either of these technologies in the sector of HPC? And maybe I would like to ask this question first to Jean-Marc, because you have to leave slightly earlier.
Sorry, my connection was not terrible. Can you shortly repeat? Sorry.
Yes, okay. So the question is, say, given that we have already seen it being quite challenging to get ARM onto the HPC market, and say for the RISC-V the challenge is still ahead of us, what would you say from today's perspective, and in particular also from your perspective as a representative of Cypel, consider, say, the biggest challenge for getting ARM-based or RISC-V-based products into the HPC market?
The ecosystem, the software ecosystem, having all the software stack bottom up, from the operating system up to the applications. I mean, all applications ported, optimized on the whatever instruction set, ARM or RISC-V, is by far the biggest challenge. Look at x86. How long did it take for x86 to become dominant in HPC? Very long, and it started at a time where HPC was a real niche market with a limited number of users, limited numbers limited number of applications. And at a time where the technology was not what it is today, it was much, much, much more simple to develop a machine. Today, we have to cover all needs. And by the way, HPC has left the classical scientific domain. HPC now is mainstream. So x86 is very dominant. Whatever we claim about the momentum we see on open hardware or on ARM or whatever, x86 is dominant. It's a fact because the ecosystem is so crucial for end users. End users, at the end of the day, need a tool. A supercomputer is a tool. So they need a tool to make science or to make engineering. This is their main concern. So we need to go through the whole ecosystem at software level before we can have a real competitive landscape with different technologies. And it takes about 10 years. It took 10 years for NVIDIA to become what it is today, starting from zero, from a blank page. It took about 10 years for ARM to become, let's say, competitive in HPC, and now they have to develop their ecosystem at the, I mean, the user level. And for ARM, I guess the cloud, the hybrid cloud aspects will be extremely useful. And for RISC-V, that will be the same story. The software ecosystem is crucial for developing the technology. And I believe that in Europe, especially around BSc having this long tradition in developing HPC software, we have very solid assets to develop software technologies from operating system to end user applications. Sorry, my answer was a bit long.
Yeah, thank you. Well, that is certainly a very interesting point, and maybe we can just follow it up with, say, Daniele. I mean, you're sitting essentially a bit on the other side, and could look at it from the perspective, okay, what stops, say, a site like CINECA from buying, say, for instance, an ARM or RISC-V based system as of today? Is it, for instance, in particular, as Jean-Marc pointed out, the gaps in the software? And if yes, what are, from your perspective, say, the biggest gap in the software?
I completely agree on what Jean-Marc say. One of the biggest gap is the software stack. I mean, compiler, library, runtime, framework, performance profiling, all to support the application is very, very important for a supercomputing center. And but I think that the second challenge is the peak performance of the system, because I remember when it started to come in supercomputing environment, GPU computing, and everyone from science field was not happy about the GPU system, because they change also the memory model to access the data and so on. But when the GPU showed that can have an increase up to 1 order of magnitude, 2 order of magnitude performance better than the host, we started to use, of course, GPU. So the main challenge are two, and these are also the challenge for the ARM and RISC-V. First challenge is the software stack, as Jean-Marc said. The second one is the peak performance of the system. ARM and RISC-V have to show that they can battle in performance x86 architecture, and to stay on the floor of HPC. I think that from a supercomputing center view, these are the two main challenges. Because if I take a look on the history of CINECA, we have very exotic architecture. Like at the moment, for example, we have Intel plus GPU, Power plus GPU, Xeon-Phi, and in the past we have Blue Gene architecture. So many different architecture, but that show that the performance in HPC still matter as I said, the software stack, because the first thing is to run the application, of course.
Okay, thank you, Danny. Now, Roger, I mean, there has now been, say, a lot of, load being, say, pushed in the direction of those who take, say, today already, say, responsibility for, say, working on this software ecosystem, and Jean-Marc already give BSC a lot of credits for the work in the area of compilers and runtime environments. What would you see as say the necessary efforts which would be required also in the future? I mean, to broaden these efforts at an European scale to really support then a broader uptake of ARM-based and RISC-V based solutions.
So yeah, I kind of agree with Jean-Marc regarding the ecosystem support, and that's true. I mean, there is a lot of this ecosystem. A big part of this ecosystem support comes from the tools themselves, and I think in order to improve the support here at the European, you mentioned the European level, or being able to make sure. I think my feeling is that the ARM ecosystem is relatively well. It's relatively well in a good position at the moment. RISC-V less so. I guess part of the usual complexity at this point is, you know, x86 has been forever, as Jean-Marc has mentioned. But one of the advantages that the x86 has regarding other architectures is that there is hardware and it's easily available. So people can port their codes, make sure they work, create ecosystems, etc., etc. I mean, the fact that x86 is not only familiar in the HPC space because it's the thing that gives us the best performance or has been there forever. It's also that it's the thing that you find in your laptop or everywhere. So people have their ecosystem already at home. I mean, that's we are seeing like small steps here. Some other vendors are creating ARM laptops, like, I don't know, Apple has been doing that, and even I think there are some Windows on ARM things. So people can start trying or experimenting their ecosystems, and if you can do that in a way that is accessible, you know, eventually people will realize that that tooling must be created. I mean, maybe people only see the reality that the ecosystem may be lacking, because then you go to the supercomputer, which is ARM-based, and then you see, oh, it's missing that super important package that I use. Okay, when you know, because nobody could port it until you go to the big machine or the big iron that ARM machine is only available in that data center. So I think some of the difficulty may be the access to the platforms, although there are initiatives regarding being able to provide access to those platforms. They may not be enough, or people may not feel compelled enough to maintain, or because actually now you have to maintain two architectures. And the tools is a similar situation. People won't request or won't demand, I don't know, optimized libraries or optimizing compilers that generate better code if they don't see any need for that. Like, and yeah, that's what I think it happens a bit. And so I think bringing hardware, even if it's not like I don't know, in the EPAC that in the API project, maybe it won't be super competitive in general. It's going to be specialized for specific workloads, but at least you have the ecosystem there, and you can start porting things eventually, so you can get the ecosystem ready for later generations where we know it's going to be more performant. That's the work. So the work should be being able that some form of hardware is available. People can port their tools, and then I think start getting the ball rolling. It's like a snowball. Eventually, things go along in that sense.
Maybe this is a good, say, occasion on coming back to one of the questions which, say, one of our attendees asked. I mean, he was pointing out that he was recently running, say, several instances of scientific libraries and also, say, applications like TensorFlow on, say, Graviton2, so an ARM-based processor developed by Amazon and available in the Amazon environment. And he was raising this point that maybe there's a need of having a better support also of continuous integration frameworks to make it even easier, not only by just being able to log into a system, but to really continuously test any kind of code which is being developed regularly on ARM-based platforms. How important do you think could these continuous integration platforms be?
I think those are essential because, as Kenneth mentioned, you cannot really maintain your software, making sure your tools are fit for the task, if you cannot verify verify in the actual hardware that is going to run. I want to highlight one example here is that Sci5 has been the company that does RISC-V CPUs, which is an American company. They have been working on creating very small boards that are relatively accessible. I mean, those are not super powerful boards. They are not HPC class boards. Nobody is saying that, but at least you can take, and I can take my software and port it to RISC-V and say, hey, it's working, or I have something that can work. It's not fast. It's not going to be like super. It's not top notch, but at least the porting there is accessibility. It's like, I don't know, a similar thing has happened in the past with those small board computers where you can just start importing. They are not fast, like Raspberry Pi. It's not a fast thing, but at least you know that if it's working here, the porting effort that in those bigger machines, it's going to be easier. At least you will have some awareness and you will have more familiarity here. So I think this is why I mentioned earlier. I mean, having hardware available, even if it's not like best in class or it's not HPC level performance, I think that's something that would help a lot in order to boost the ecosystem actually. And the continuous integration, yes, it's an essential bit that, I mean, I can generate RISC-V code, but if I cannot execute it anywhere, it doesn't make any sense, right? So, I mean, here at BSc, we have some. Well, we use actually some of those boards in order to test our developments in RISC-V. But those were like the initial version of those boards was very expensive and wasn't very accessible. So what if in the future we can have something more accessible? Eventually, this will lead people to ARM or RISC-V architecture, and eventually people will be more familiar with that. That's what I mean. My feeling is that the Raspberry Pi, for instance, and other single board computers have helped here, have created familiarity and reduced the barrier entry to ARM architecture. So a similar thing could happen with RISC-V, and this is important, I think. So yeah.
I mean, Fabrizio, you have some experience in making hardware available, in this case with our media cluster for testing purposes. Would be, say, in the deployment of a continuous integration system for, with, say, support of continuous integration be as a possible next step from your perspective?
For sure, we have to implement a complete chain of process to make sure that what we deliver to our end users is something which is stable, reliable, and is fulfilling the requirements of the users. So CI/CD is a must at this point. And the previous discussions about the ecosystem are going to be a key factor to deploying platforms that users can use. Let me raise a flag in this direction, and it is the fact that we have to hook up with ISVs to make our proposals suitable for industry. In this moment, we feel that the proposing ARM or RISC-V based platform to industry is basically a no-go proposition, mostly because all of them are asking us, where are the applications, the standard applications? And we are failing to name a sufficiently large number of applications that run on both ARM and even lesser to RISC-V. So I think that the first, I don't want to say the low-hanging fruit of any CI/CD should be engaging with the ISVs, convincing them of the value of porting their applications to ARM and maybe in a couple of years to RISC-V, and then go flat out to industries as well as academia with a complete set of applications and a suitable ecosystem for industrial-like applications. In my point of view, academia and research centers are fairly open to RISC-V and ARM, and we see that the major deployments of ARM-based platform have already taken place at academia. You know, the RICAN, the system at the US lab, and the Isambard system. These are a proof of the fact that RISC-ARM in this moment is ready for prime time in academia. The next step is going to industries and make sure that they endorse this. And this is coming only after having the applications ported and as optimized as possible.
Now, if you look both at ARM as well as RISC-V, I mean, they are, well, particular ARM is say, the current instruction set architecture, which is used for most of the cores which are sold worldwide, but also RISC-V is ramping up quite quickly. But then we are essentially talking about markets outside of high-performance computing. How would you, and maybe you, Fabrizio, would be, say, in the best position to give, say, a first answer to that. How would you see here potential synergies between these different markets, and given that say HPC is still a bit of a niche market, what will be the important factor we have to pay attention, say, as an HPC community, to see say this the uptake in HPC also to be further pushed, and also for instance to address the point Daniele made about say performance, because that's eventually closely linked to the underlying technologies.
Yeah, sure. I don't think that there is any architecture fitting all the needs. So in HPC, as well as in other field, one size doesn't fit all. So up to now, we have the x86 ISA, who basically covered all the with or without accelerators. Moving forward, I see more and more different partitioning of the system with specific architecture bringing specific ISAs with it. It is a picture very well designed for different workload, and I think that this is direction to go. It is already part of the European calls 2020 or 2019, don't remember, where some of the projects were endorsing different modules with a different architecture, each of them specialized for a specific workload or for a specific application. I think that's the way to go, because we'll allow the user to select the best architecture for the requirement of the application.
So with that, I mean, you already say are essentially say sketching a future where we are continuing to have say a large diversity in terms of the different hardware solutions, and that brings us to some extent again back to this question of say software as say the abstraction layer between say the complex hardware and the user. So going back to you, Roger, I mean, what do you see as say the key things which are required in order to make the life also of application developers in the future easier?
Okay, that's a difficult question.
I can talk. We should make life easier.
I think we want to make the life easier because so my feeling is that maybe we have been repeating this mantra for years, but I understand at some point, I think that in the future it will be like a common thing to have a specialized hardware that will be presented as a user as of an accelerator. So it may be integrated, it may be packaged very well, but it will be presented to the programmer as an accelerator. And I mean, one thing that we at BSc, we usually kind of favor designs more like NPI plus OpenMP, things like this. And OpenMP, I believe it's relatively well in a good position here regarding to work with those accelerators. I mean, at least in the context of API, there is a mode where you can offload work from the GPP, the ARM core, to the RISC-V VPU, and we offload vector code. So so I think so we are looking at it's a CPU that could be run as standalone, but we can look at it as an accelerator because we know it has specialized instructions for us. I mean, why those instructions? Why a similar approach couldn't be used in general? Like so we have been focusing in vector processing, but some other of the accelerators are care more about machine learning, and there is some other kind of specific accelerators. So how we can make the life of, so programming accelerators is usually difficult. And I completely agree with Daniele regarding the GPU support. At the beginning, it was like difficult, but it gives you a lot of performance. So I think those models where you can offload work, or models that understand accelerators as a first-class thing, not something that is not an addition thing into your programming model, not something that, hey, this is an afterthought of the programming model. So I think those will help a lot. We have been working with OpenMP. We believe OpenMP is standard enough, and it's in a good position. I accept that may not be the perfect interface for offloading in general, or for the accelerators. There may be limitations here, but then this is one option we believe makes sense. Other companies like Intel have been presenting their own APIs where they try to bring like a unified vision of everything, of computing in general. Probably those models, I think models that, that accept the fact that, I mean, a CPU is a general purpose thing, and then every application may have specific workloads which can be accelerated. And those are the places where we have to kind of reduce the complexity, the pain here.
So you are to some extent saying that I mean, the strategy at BSc is in particular, say, focusing on, say, supporting, say, standard programming languages, then with additional directives, and then therefore it's say that you have an accelerator with different instruction set out here, like for GPUs, is essentially then largely hidden, and the user doesn't have to care about that. Looking at it from, say, the more data center perspective, I mean, Daniele, what is your experience with, say, early users in trying to engage with this new instruction set architectures? And what would be, say, your bet in terms of future programming models?
I mean, at the moment in CINECA, we don't have production system based on ARM architecture, and of course on RISC-V architecture, because at the moment it does not exist.
You're a bit faint, Daniele. Can you come closer?
Yeah. Can you hear me now?
Okay. Yeah.
It's better.
Yeah.
Okay. Now, just say that as a supercomputing center, we are working a lot of also in ARM system, even if we don't have at the moment a production system based on ARM architecture. I think that in the next round of production system, one of the system will be, of course, based on ARM. I think that this is something very difficult to avoid, because the challenge on the ISA architecture is very strong, and now x86 architecture find a very good opponent to all the CISA. I think that it will take more time to RISC-V architecture. At the moment, as I say, does not exist a high performance RISC-V processor. I think that a company like C5 are pushing a lot, but they are not the only one. And we can see also BSE that are working on RISC-V accelerator and the API project itself. So a lot of people are working on the RISC-V. I think that ARM is not more a future, but is a present. Fujitsu showed that it's possible to build an exascale system or almost an exascale system with an ARM architecture. And I think that in 5-10 years, we can also see a similar situation with the RISC-V, or I mean, I hope so, because RISC-V has also a very good capability because the ISA is open, so everyone can also develop specific instruction to accelerate a specific workload. This is very, very interesting, in particular in this area where there is a lot of dark silicon in the chip, and the specialization of the component of the chip is something critical to achieve a very good performance. So I'm very happy to live in the era of the architecture battle, because it was a little bit boring the last 15 years. Now it's very, very complex also to select a system that is capable to optimize the workload of a supercomputing center. And there are many viable solutions that all of them are very nice: x86, ARM, RISC-V, GPU, FPGA, so custom accelerator, AI accelerator, so on. So I think that the battle is open, and even all the component, all the ISA have their own ace in the hole to win a procurement in supercomputing center for an exascale, for future exascale machine. I think that this is very nice, and hopefully this will happen even in the RISC-V architecture, because, as I said, ARM is here and is here to stay.
Before I have a follow-up question on that, I would like to remind attendees, please use the Q&A window, I mean, to submit questions so that we can open, say, this discussion to, say, more of you. But then I would like to have to ask a follow-up question to Daniele. I mean, you recently had this transition from the Marconi to the Marconi 100 system. That means a transition from, say, the very widely used x86 instruction set architecture then to the power instruction set architecture, which is much less commonly used, even so it had been used for, say, the most powerful systems on in the top 500 list. What are, say, have been your experience with these transitions? Did it, for instance, also raise the awareness of the application developers in terms of making their code's performance portable? And based on that experience, what are your expectations if you would say tomorrow announce an ARM-based system, of whether you would have, say, a less painful transition, assuming that it was for some of the user probably with some pain to get onto this new system, not only because of the GPUs?
Okay, I think that supercomputing center are the transition among architecture, even the different architecture, like as you say, x86, power, now again x86, what happens in the future, we don't know. I think that supercomputing center are quite it's quite common also to use like exotic architecture or different architecture. I mean, the generation among supercomputing as I said, is also performance driven. So if an architecture can show, if an architecture or a platform can show an higher performance, and we see that they have a sustainable software stack, the race is open for a supercomputing center. This is also why our flagship system is now power plus GPU, and we came from a standard x86 system. I mean, a standard mixed standard. I mean, between the standard like Skylake system, Intel system, but also Xeon-Phi, which was another exotic architecture. And so I think that in a different way respect to the cloud or hyperscaler, then they prefer to stay on legacy architecture, like mainly based on x86. If the generation of supercomputing, the system of supercomputing center can vary a lot. Even in this case, our application are quite ready to move on different architecture. This is also why very famous scientific applications are quite easy to port on a different architecture. It is not the same for performance portability. This is open a very different story, but it's just to compile and run at the moment. I think that all the application in that we usually use in a supercomputing center are quite ready. This is also why it's not so critical to jump on different architecture. And I mean, performance is always tricky, but it's not always a problem of ESA. Let's say, as I said, as instance. I can report the Xeon-Phi architecture on the CNI landing that we currently have in the use on this particular architecture. The ESA was the same of x86 for the Xeon standard processor, but the performance on different kernel was very, very different, and they have the same ESA. So it's not, I think that this is not more a problem of the ESA, so on the ARM, x86, power, and so on, but on how the architecture work, and this is independently even from the ESA. So the problem, I don't think that is the migration between ESA, but it's among the architecture. And but as I said, supercomputing center are, in particular CINECA, we jump a lot on different architecture. Now we are ready for another jump, even for ARM, even for RISC-V, and so on. So I think that from our side, we are ready to work on different architecture.
Okay, thank you. Now we have essentially heard that I think that was a kind of consistent theme with among all of you panelists, that there is still a lot of work ahead in getting full support of ARM, and even more when it comes to getting to a higher technology readiness levels for RISC-V. The European Commission has through EuroHPC and now also to some extent in the Rise in Europe program started to basically lay out the support program which we can expect in the next coming years. Knowing that, I mean, what would you consider as being what would be on your wish list in terms of where should be the biggest investment being made? Maybe Fabrizio, if you could start on this question.
Well, we have to prize the EuroHPC and the European Union to have started back in 2018, if I'm not wrong, the EPI 1 process, and this has put the building block for the first wave of truly European processor and ecosystem. This is a remarkable vision that has started some years ago and is giving the the first results in these very days, as Jean-Marc has been showing. We know that the EuroHPC has already invested significantly in the European pilots. One called the UPEX, and the second is the European pilot. And this is a very good follow-on of the initial investment, as well as on SGA, on the API, the second version of API, where the European is putting money. Now that we have closed the hardware loop, or near, then I think that a significant amount of investment should be applied in developing, as we have seen, the fully ecosystem, and in having the ISV supporting their code on this new architecture. I think this is the next goal of the European Union and EuroHPC, and this will provide the full ecosystem to engage industries in the new processors. And I know that having ISV supporting the application is a sort of Sisyphus task, but it is something that we have to go through to have a compelling reason for industries and everybody else to use these processors and ecosystem.
Maybe a follow-up question to that, because you already say coming back to this question about the ISVs. At least my impression is that, say, the investment into the porting of the ISV codes is something which, say, a number of ISVs are willing, I mean, to take. And I have, say, a bit the impression that it's more of then getting such new products to the market and to understand of how can we actually, say, support solutions then for different architectures with different instruction set architectures in the long term, where, say, at least some ISV seems to feel challenged with how they can get the right balance with the cost which it is generating. If that say assumption is true, and you have more experience on that, what would you think would be then good support models? So how, coming back to this question about what kind of public funding should be there to indeed, say, promote this uptake by ISVs?
That's a very tough question, because it is involving some rules or sort of KPIs that for me is difficult to say. I understand that ISVs are a sort of in a sort of let me say catch-22 situation. They want to have a market for their product, but if there isn't the application ported, there is no market. Okay, so we have to break this insane loop and make sure that at least somebody is doing the first step. Given the fact that ISVs, as of now, do not have a compelling reason to port their applications to the new architecture, we have to turn the other way around this loop and having the application available, and then a market will develop thanks to the availability of the processors and the accelerator. How this should be declined over the European Union and EuroHPC funding, that requires some more, in-depth thinking in this moment. But we have to sort out this insane loop in this moment.
So would you think that, say, support in, say, financial support in lead customers would be, say, a mechanism that could help here? I mean, that's something which is done, say, in at least when, say, the customers are more on the public side through, say, PCPI, and in particular, say, PPI model. So, that's for to explain these acronyms. So PPI stands for Public Procurement of Innovative Solutions.
I think that we should implement in this moment the classical co-design process where we have an end user, which is a guy using the application. We have to have a technology provider for the hardware, and we have to have somebody in providing the code. Mm-hmm. In this way, I think that we can put all the eggs in the same basket and make sure that this is resulting in an end user, if you want, a sort of pathfinder end user, implementing the application and then having the support of the hardware vendors as well as the ISVs. For this, having the ecosystem is mandatory, I agree with you, and having a strong end users who can lead the way is as well as mandatory. The data center may be the supporting infrastructure for showing that this may be done at the application level, as well as industrial end user for industrial level.
Okay, we're coming, say, towards the end of the allocated time, so I would like to end this round, as I see currently no open questions in the Q&A, with, say, a kind of a standard classical question to, say, the remaining panelists, looking into your crystal ball and try to say, hypothesize and ideally also with some reasons on how say things are going to develop over the next couple of years. So where do you think will, say, the ARM and RISC-V in the HPC environment stand in 3, 4, 5 years from now? Maybe starting with you, Roger.
So, okay, my feeling is, so looking into the crystal ball you mentioned, in the future, my feeling is that we are going to see more ARM deployments, mostly in data center, perhaps less so in HPC, because ultimately the decision is driven whether the CPUs deliver the desired performance. So we may have test systems, but if those test systems don't prove worthy, then those are not deployed at scale. I don't know, as I mentioned earlier, given the reliance these days on accelerators, you know, like GPUs and stuff, perhaps future CPUs will be like good enough for general workloads, and x86 alternative will be able to deliver the desired performance. So I don't know, this might tip the HPC choices to other aspects like energy efficiency for those general purpose CPUs, or even the cost. Like, I mean, I'm buying this vendor because it's cheaper. It's cheaper and gives me similar performance, and the extra mile I need for my HPC applications, I deliver it using GPUs, for instance. I don't know, in that sense, given that the specialized hardware in form of accelerator for particular workloads seems to be a hot topic, I want to think that RISC-V may enable some kinds of those designs. So you may find those small accelerators, and those are based on RISC-V. But if you ask me, I don't foresee at the moment, sorry, I don't want to be a bit negative here, but I don't foresee a RISC-V HPC core per se in 3 years time frame, maybe longer, like give me 9 years or something. Maybe we're going to start to see something that is realistically usable in HPC. Maybe I'm wrong. I don't have a crystal ball that is completely perfect, but at the moment, I don't think it's going to happen in the medium term, maybe in the longer term. Yeah, that's my vision.
We know how volatile, say, these developments are, so I mean, we will not hold you accountable for that prediction. Daniele, what's your bet on the future?
Okay, for ARM, I expect fast rise, in particular in HPC, cloud, hyperscaler market. ARM for HPC is not the future, but is the present. Fujitsu proved it with the A64FX. AWS proved it with Graviton 2 on cloud field. NVIDIA will be the same for both with Grace. Apple, it's working a lot for low and middle system with ARM, and now it overtakes at the moment the x86 architecture. So the race of CISC versus RISC architecture is started, and it will be a nice race. We will see. So ARM focusing HPC cloud hyperscaler in the next 3 years. Instead, for RISC-V, I mean, from my view, RISC-V will grow a lot in embedded market and only marginal at the moment in HPC. We will probably see the first middle, high, entry-level system on chip based on RISC-V, maybe from C5, maybe from some other research from some research center or other company. But these systems will dedicated on research innovation and not based on real production system. We don't think that RISC-V will enter in production environment like CINECA or the supercomputing center in the next three years. But because this is still a young technology, but I see a very promising futures. And let's see what happens in the next 5, maybe 10 years for the RISC-V. I think that this will be enough time to have a competitive product for HPC cloud and hyperscaler market based on RISC-V.
Okay, thank you. Reach already the full hour, but I would, since Fabrizio, you started this event, I will give you, say, the opportunity to, say, give your future views to the crystal ball, and maybe you could take it then also as some for some closing remarks for this event.
Sure, thanks for that. I think that we will experience way earlier than 3 or 5 years the future of ARM and RISC-V. We know that there are some looming acquisitions of both architecture by large vendors with who may, with just one decision, decide the life or the death of both ISAs. And I'm saying that being totally outside the decision process of these vendors. My hope is that both of them will decide to go on with this architecture because there is a specific role for them in the market. As a closing remark, I think that there is a bright future for integration and the synergies of these architecture, of these two architectures in the future for scientific and industrial applications. And there are a lot of goodwill people investing money, resources, and effort in making sure that an ecosystem will be created. I'm sure that the Open Edge and the HPC initiative will play a role in making sure that these two architectures will have a future and lobby in the market for having them working side by side and exploiting more synergies than wars. With this, I think that we should say a big thank you to the organizer of this event and to you, Dirk, for driving the panel, and invite all of the attendees and speakers to a future events that we will organize in the future. Sorry. With this, I return the control to Karti for the final remark.
I mean, I just want to repeat, I think it has been a very good conversation. I really enjoyed listening to all of you, actually. And thanks again to all the speakers and panelists for making this a good time to listen to. Hope we can meet again soon in some other event.